So in today's lesson, we're going to talk about simplifying expressions using the greatest common factor. Now, we've talked about, you guys have seen in the past about how to factorize a number, or prime factorization. We call them the trees. You guys talking about the tree diagrams. So for instance, we'll look at example 1 here. If we have 120 and we need to factor it out into prime numbers. Now remember, a prime number is a number that only one in itself can go into. So if we start off with 120, we can factor 120 several different ways. Let's just start off with 2 would be the easiest. So then 2 times 60 is our prime number. Then we break that down into 2 times 30. And we're running out a little bit of room here. This is going to break down to 5 and 6. And then we'll just bring 6 over here. Breaks down to 2 and 3. So then the prime factorization of 120 would be 2 times 2 times 2 times 3 times 5 would be the prime factorization. So each time you get a prime number, I would just circle it. So we get prime number, prime number, prime number, prime number, and each one of those circle ones, then we'll put from least to greatest and go that route. So we can try another one. We'll try 924. And so 924, again, can break down. We'll start off, again, we can use 2, so 2 goes into this, 462, I believe. So then we can break this one down into 2 and 231. And then this one here, we can actually break down, 3 will go into this one, so 3, and it goes 77 times. And then 7 would obviously be 7 and 11. So again, prime number, prime number, prime number, prime, and prime. So our prime factorization would be 2 times 2 times 3 times 7 times 11 for 924. Now when we're talking about prime factorization can be used when determining the greatest common factor, which is just the product of the greatest integer that divides without a remainder into the coefficients and the greatest power of each variable that divides without a remainder into each term. So some of these are going to look a little different. It's going to look maybe a little tough, but it's not as bad as it's going to look. Okay, so we need to find, let's take a look at example 2. We need to find the greatest common factor of 6a squared b cubed plus 8a squared b squared c. So first what we're going to do is we're going to take a look at the greatest common factor of 6a squared b cubed. So we know that the greatest common factor, we know if we factor out 6, it becomes down to 2 times 3. And then we're going to write times A times B times B times B. And that's 6a squared b cubed. Then we would take 8, and 8 breaks down to 2 times 2 times 2 times A times B times B times C. Now that we do that, we look to see what they have in common. Now this is going to be a little different than least common multiple where you take an add. We're just looking for what they have in common, so this is where it becomes pretty easy. We notice that they have a 2 in common, and that's it. So our first part would be 2. Then we notice that they share an A here, share an A here. So when we have 2 A's, it becomes A squared. Then we notice that they have 1 B in common and 2 B's in common. So that would be b squared. And that's all they have left. They don't share another c. So the answer, the greatest common factor of 6a squared b cubed plus 8a squared b squared c would be 2a squared b squared. So let's take a look at another one. We have 8c to the 4th d squared e minus 12c cubed d to the 4th e squared. So again, we're going to do our prime factorization of 8, which is 2 times 2 times 2. And then we're going to do c to the 4th, c times c times c times c. And then d times d, and then times e. And then our 12 breaks down to 2 times 2 times 3. And then we have 3 c's, 4 d's, and then 2 e's. And we'll try to get that in that picture. So now we look and we have in common. We have a 2 in common and another 2 in common. So 2 times 2 is going to be 4. And then we share where we have 1c, 2 c's, 3 c's. So c cubed. Then we have 2 d's, so d squared, and then 1e for e. So our greatest common factor would be 4c cubed d squared e. Now if you look, this is a little bit easier by looking at this, that you see once you find the greatest common factor, your prime factorization numbers of 4, you can look at your variables and just determine which one has the least amount of variables. So for instance, we have a c to the 4th and a c to the 3rd. We obviously can tell that they share at least c to the 3rd, so we'll just take the c to the 3rd. The d squared, they have a d squared and a d to the 4th. We'll just take that d squared, and then we have the e, we'll bring the e down. So you're just looking for each of the variables, which one has the least exponents on it, you just take that one. Otherwise, you could just do it, you can draw it out like I have done here. Now let's take a look at example 3. We have 6x cubed plus 8x squared minus 2x. And what we're going to do is we're going to look at all three of those terms and determine what do they each have in common. So if you look at 6x cubed plus 8x squared minus 2x, technically we could go through and we could factor all that out and go through that. But you can look and say that 2 goes into each one of those. So they all have a 2 in common. And then they each have x cubed, x squared, and x, so they each have an x involved. So now that we've done that, what we're going to do is we're going to put our parentheses. This is talking about factor each polynomial completely. This is what it talks about when we talk about completely. So then we go, what times 2 is going to give us 6? We know that 2 times 3 is 6, so we have 3. And then what times x is going to give us x cubed? We have to get 2 more x's, so that would be x squared. Then we bring down our sign to get plus here. So then what times 2 gives us 8? Well, 2 times 4 gives us 8. And then we have x times what would give us x squared? We need another x. Minus, what times 2 is going to give us 2? Be 1. And then what times x gives us x? It's 1, so we already have it. So this, we want to factor out the polynomial completely, and the answer would be 2x times 3x squared plus 4x minus 1. So let's try another one. We have 9x to the 4th y squared minus 9x to the 6th y. And we need to factor this out completely. So we notice that both of them have 9 in common, so we'll take out the 9. They both have at least an x to the 4th. Remember, we take the variable and take the smallest exponent. So in this case, we have x to the 4th. And then we look at y squared and y, and we see that they both have the y. Now we're going to figure out what times 9 is going to give us 9. We know it's 1. X times x to the 4th, it gives us 1. We need another y in order to get to y squared, so our factor it out would be y. So 9x to the 4th times y would give us 9x to the 4th y squared. We bring down our sign, and then we know that 9 times 1 will give us 9, so we need 2 more x's. So x to the 4th times what would give us x to the 6th? It would be x squared. And we already have our y there. So our final answer would be 9x to the 4th y times y minus x squared. Now let's take a look at example 4. This one gets a little bit trickier, but not really if you just pay attention. We have 3p plus 3 divided by 3. And the instructions tell us to simplify each expression. Well, we look at the top, and the bottom we can't factor out. 3 is a prime number, it's done. But 3p plus 3, we can factor 3p plus 3 out. So we can take out 3p plus 3, we know that they have at least a 3 in common. So then we multiply what times 3 is going to give us 3p. We know that it's going to give us p. And then what times 3 is going to give us 3? Well, it's going to be 1 over 3. Now that we have this, we can reduce it and simplify it. So we can cancel out the 3's, and it would leave us with a final answer of p plus 1. And we'll take a look at our final one here. We have 5x minus 25x squared over 5xy. So again, on the top we can factor. We can't factor anything on the bottom, but the top we can. We can take out at least a 5, and we can take out an x. So then what times 5x is going to give us 5x? Well, that's 1. We bring down our sign. What times 5 gives us 25? That would be 5. And then what times x is going to give us x squared is another x. And then we put that whole thing over 5xy. And from here we can reduce it. we can cancel out the 5x and a 5x, and it would leave us with just the y. So our final answer would be 1 minus 5x over y.